Hello everyone, this is Amir El Said. In this presentational not a tutorial video, I'm going to show how powerful it is when it comes to automation. First of all, I prepared CAD drawings, includes the structural system, columns as points, beams and walls as lines, slabs as polylines. This is the first story. Second story. Third one. Fourth one. Story number 5. Story number 6. And finally the last one, story number 7. Then, using an automated data extraction method, I'm able to bring the 2D coordinates for this structural system from CAD to Excel. Let's go to this Excel. In this Excel, we have here, this is the, I call it the control sheet. Here I added those buttons. Each button is responsible to do a specific task. Through the VBA macro, I coded and assigned to each of it. Here is a model. Here in this sheet, we have everything with blue color, by the way, is a user input. Enter directory. Here I can enter the directory where I'd like to save the model, the ETABS model. I have here 3 options for refreshing the window while ETABS is modeling the elements, element by element. Here I have multi-choice to ask the ETAB to show one time after it complete fully, or after adding each type, means frame, one time after frames, which is column and beams, and one time after walls, and one time after slabs, or for each single element added. The better option will take the for each type. At least we can see what is modeled and to see the progress gradually. Here in the structure data, we have this sheet as well, having a user input by typing. Here it was typing. Here it was a selection from a list. Here it's a typing as well. The story names, height, the levels are calculated, the elevations are calculated, automated. Here are the other characteristics or properties for each story. Here is the load pattern. This is by typing input. Here by typing. Here also by typing. The type should be followed as per this pattern, since it is matching with the ETABS. Load combination. It's user input by typing as well. Normally this sheet will be fixed for most of the projects, since it is as per the related code. Here I added as per ACCE 7. We might have a slight change as per the project requirements, but this is a common ones here, also by typing. Frame sections, here by typing as well, I can add the beam and the column section names and the dimensions as well. Also here I can input the modifiers for the columns and here for the beams. This is usually the 3 modifiers we are playing with or we are modifying. For the shell sections, we have here the names of the shells, whatever it is a slab or a wall, assigning the related thickness. Also we have here the wall modifiers and the slab modifiers. When it comes to connectivity, it means all of this input. This is the 2D coordinates of the structural system from CAD. This information fully came here using the automated method from the CAD to Excel. It's a 2D coordinates for all the stories. Okay, and we have as well for the walls If you notice here, the Z or Z is always 0 because, as I mentioned, it's 2D. Here the wall opening, the name of the door or window, along with the concrete height, bottom and the top of the opening of the opening of the door or the window. Here this sheet is responsible for modeling the top portion and the bottom portion of the door of the window, and if it's a door, it will have a top portion only. It's 2D as well. Finally, the slab 2D coordinates. So all of this coordinates 2D, as I mentioned, it came already from Excel using the data extraction automated method. So if we go back, let us start. Here we have the first. I'm going to click the first button, which is reflect Z coordinates. It means this button is responsible to convert all the 2D coordinates we saw in this connectivity sheets for the frames, for the walls, for the slabs, for the wall openings. Each row of this sheets, it will have a Z not equal to 0. It means the third dimension will be entered for each single point of the model. Let us go. I will click here. Z coordinates reflected. Let's go and check back. Frame connectivity. Now the Z is not 0 for all. Now it's adjusted as per the related levels. Same for the wall connectivity. Same for the wall opening modeling sheet. Same for the slab. So now I think we are done here with this Excel. Let's go to start the modeling. First of all, this button is responsible to open the ETABS application. Then it will create a number of stories as per exactly this sheet. Let's go open ETABS. There is a notification here. I included in my code to pop up a notification after each button to ensure that the code is performed or executed successfully. Okay, we'll go back to the ETABS. I will cancel this window. One window is enough. 3D view, right click. We'll go to check the stories. Yes, it is. Here we are. Story from 1 to 7, each one having the height and the elevation and everything as per entered in the Excel sheet. Cancel. Cancel. Let's have a look on the materials. Still the materials as per the program default, nothing changed. Here the rebar as well. Let us have a look on the frame sections. This is a program default. Nothing is still added yet. We can delete all. This is the default for the program. Since we are not going to use it, we will add ours using the automated way. So as all of you may know, we need to keep one only. This is as per the program. We are going to delete it later once our stuff is added. Okay. define. Let us also have a look on slabs. We have here the default. We're going to delete it later. Wall sections, also the default. Let us also check the pair labels. Spandrel, nothing, so perfect. Now we can start the model. Here, this button, once I click this button, the model will be started adding all the elements, and it will define or modify the material properties related, and it will define the sections along with its modifiers, and everything is going to be completed automatically. So let us see. Here for each type start modeling. I will go to the ETABS to see it's refreshing the window. Now the columns and beams are added. I moved the window to see all the columns and beams are added in one time, just in 3 seconds. Now we are waiting for the other elements to be added. Still the automation process is in progress, but in the background. Once it finishes, to refresh the window. See, refreshing the window after adding all the walls. Then one more time for the slabs, which is running right now in the background. Yes, refreshing the window, notification here, structure models. So once we go to the ETABS again, we'll have a 3D. See, this is our beautiful model. See, we are going to have a look again, but let us adjust some settings. We'll go to the display, black background. We will go to here. We can define show the object by the colors for each. Okay, so let us have a look on the frame sections. This is one. We'll delete it. Here it cannot be deleted because it is already considered in the modeling. This is the beam. This is the name, this is the dimension. It's not a big deal here to change it to the beam for the design. The modifiers are also automated for this beam as well. The name, the dimensions, we can change it to beam for the design. It's not a big deal at all. Modifiers, same for this beam. The column, since the default adding frames for the program is a column, so we are not going to change the design of the column since it's a column already. Here is a column name, here is a material, and here is the dimensions. Let's check the modifiers. It's okay. Here, okay as well. All of this are included in our automation, as we see here. So we can say okay. Also, let's see here, this is a concrete. Everything is adjusted as per the concrete, and here for the repair, everything is okay. Now let's see the slabs. This is the program default. We're going to delete. It can be deleted since it's not used in our modeling. Here we have the Holocaust 150. The modifiers, slab, here is a slab 200, material, thickness, modifiers, everything is okay. Same for the 265, same for the 320, 400, finally for the 500. Okay, let's have a look also in the walls. We're going to delete the program default. Let's check the 200 wall, 200, the modifiers are okay, thickness, name, everything is super perfect. Okay, so right now now we check the definitions. Also, we have here for the assigned peer label, for each single peer modeled, and for the spandrel as well, a peer label and a spandrel label are defined and assigned to each related shell. Here is the proof. All of this. Here for the spandrel. Okay, now let us see from another point or from another observation angle. We will select the slabs. Okay, show selected only. You can go at floor by floor. We will here allow to show the section for the shells. We can also increase the font a little bit. Let's have a lock in depths. This is a 265 slabs. This is a 500, 500, 265, 150. As you see here, all the slabs are added properly, modeled in the same accurate location, having the related assigned section. This here, as we see here. Okay, let's go to the next story. Here as well. Next level. Here as well. Okay, so let's have a look on the first. Let us disable the shells and enable the sections for the frame, since we are going to see the frames now. Select object types. We can select columns and beams. Show selected only. Here we have all the columns and beams, each with the related assigned section. So let us increase the font a little bit. Here is the first story. As you see, everything is super perfect. We have here semi-ring beam, we have here ring beam. I will tell you why later. Level number 4. Fifth story. Story number 6. And finally, number 7. So now let us see we will again go to disable the sections from frame and go to 0, since we are going to see the walls. Select object type walls selected on. So here, if you notice, for each wall, the wall section is assigned, and for example, when we have an opening, architectural opening, whatever it's a door or window, the bottom and the top portion within a wall, it is intended and considered in the code to take the same section of the wall. It's clear here. Okay, here as well. See, nothing is mismatched, everything is perfect. This walls as well. Actually, this building I created from scratch, just from my imagination. This is only for the presentational purposes. Here. Okay, I believe it's time to see the beers and spandrels. The beers are added for each thing, automated. In automated, everything is automated. Beer is added here, spandrel, beer, spandrel, as we see here. See, this is the beauty of automation. Everything is very accurate because automation is allowing to just draw whatever you want in the AutoCAD, then by some programming skills and some automation, everything becomes true from its stage of dream. See, not a single point, even not a single point is missed. Okay, I believe we are done here. Let us see a view again for this building. It's a pyramid shape. Actually, it consists of some letters, and each floor I'm going up, I'm canceling 2 letters. So here, yeah, this building is a name. See, this is the beauty of automation, because actually this building, when you are going to make it in ETABS, normal way, it will take a lot of time. But when it comes to draw it in AutoCAD and then convert it into like what you see with all of this details in just 5 clicks, it's a magic, right? Let us have a look from the other side. As much as I can, I want to show you from every single angle to see how beautiful it is. Okay, right now we'll have object walls. I need wall selections, and I need to select one more column, which is this one, and one more beam. See, this is the true innovation. Actually, this is the place where the innovation is born. Proud, very proud to say that actually. Okay, see, this is all the view. So the walls are created especially in this curved ways and in this alignments, having all this structural to show this word, exceed precast. If we go to the plan wise, and if we make the extruded view, and we are going to have a look from the plan. So this is, as I told you, it's a pyramid shape. Every story we are going up, I'm canceling 2 letters. This is we can say this is the double bars coming from the foundation. Again, show all. This is the extruded view. some areas are intentionally kept as open just for the purposes of the here all of these areas I kept open area for the purpose of the stairs, lifts and skylights as well. So now I believe we are ready to run the model to check how accurate it is. Let us divide this frame here to ensure more connectivity. It's okay now. Let us see the joints. It's fine. Wanna see some more magic before the run? Okay. Here, once I click here, all the load patterns I defined in this sheet is going to be added automated way. But before doing this one, let me open the ETABS, go to the load pattern. Still nothing is added. This is as a program default. Go to the load cases here as well. So when I click add load pattern, load patterns cases added. We are going back to the ETABS, the load pattern, see exactly as we want in less than 1 second. Go to the load cases. Yes, it is there already. So this button, it was adding the load pattern, and for each load pattern it is adding the same load, it is adding a load case for the same. Okay, one more magic. Here is empty, the load combinations. Once I click this button, all these load combinations I entered here, it will be reflected into the model in 0.2 seconds. Add load combination. As I show you here, still nothing is added. When I go here, I click add load combinations. Load combinations added. We'll go to check. Yes, here we are. I will hover over each one faster than opening and closing to show the load combinations. This is the envelope for the surface, envelope type. All the load combinations are added here. Let us open any of this. See, it's showing as per the hover over outside 0.6 dead plus one wind. Let's jump to this one. The surface is total dead plus total live. Here's the total dead is defined as well. Total live. Let's jump to the ultimate. Exactly as per the SCCE 7.5. Let's open this one to catch. Yes, it's showing exactly. This is the ultimate one. So I believe no more magic. We are going to first of all, I will enter before running the model. I will this folder I created specially to save the model here. The folder is empty. I will take this directory. I will add it here. One more slash. I will name the model innovation place.edb, the ETABS extension. So I will go back and I will save the model. The model is saved. If we go back to the folder, we can see the model is saved here with the same 1 second ago, 1 minute ago. So now we can run the ETABS. I will go in the 3D view. I like this view from here. Run analysis. Once I click this button, it will run the analysis. Now it's checking the creating analysis model for all of these elements added in automated way. Creating analysis model for each story having consists of some elements, columns, beams, walls. Walls are divided into some portions above the door, above the window, below the window, some another types of shells as well, which is the slabs, and the frames, as we know, it's the columns and the beams. So he's now creating analysis model, means it's connecting all together to can change it into a finite element model, then to able to use the stiffness matrix to solve the indeterminate structure. Then it will come out with the related results, forces, deformed shapes, and all of this. Now it's going as it is showing here. It's coming from up to down. Finishes story 7, 6, 5, 4. Now in the third story, he is creating the analysis model. After the analysis model created, it will start running the cases, including the model case. After that, after the run process is finished, it will show the deformed shape for the first case loaded, which is the self weight. By the way, this we are running now against the self weight since no additional loads are added. This is as I said before, for presentational purpose only. After that, actually the purpose of this step is to show that the analysis running is also included in the automation, and to check the last analysis run log, to prove that we have no warnings, we have no instability condition, everything is alright. So now in story 2, after story 2 we will go to story 1. Coming back here, if we go back to the CAD until it's finished, now still story 2. As you see here, this is the beauty. Here we have the points as column. Each is polyline for the slabs, lines for beams and walls, and also for the door openings and window openings. It's just one line, and the programming is handling the other columns as points. And let's go check. Still in story 2. This running actually depends on the computer or the laptop performance. So when you have higher performance, this will have no time. Also, it is having no time for the lower performance laptops, but this will happen from the next time. Means once the model is run for the first time, the other time it will not take time, since some files here it will be created already and no need to create again. The model will read from it already. Yes, now it's a little bit. We're still in the plus story 2, it's finished. Now in story 1, it's almost done, almost complete. The last story is here. You can also scroll the video, not to wait. You can scroll the video and you can see the end of analysis. It will be within a very few minutes. I'd like to say as well that it is always a very powerful improvement when you engage programming skills in your field, whatever what you are doing, what is your work, what is your task. Automation is not anymore the future nor the present, it is past already. It is really powerful. As you saw in this video, just some lines and points and polylines in the CAD, each with a specified layer. Then by 5 or from 3 or 4 minutes you can transfer this one from the CAD to Excel, and if the Excel is pre-programmed as the one I have, after 5 clicks only the model is completed. What a impression, right? Yes. Analysis model created successfully for all. Now it will start running. Now running the first case. Of course, all of this time what we waited, it will take less than 1 minute if your computer or laptop performance is higher than what I have here, since this one is a little bit older. As we said, this is only for presentational purpose. Of course, running this model will not take more than 2 minutes, as all of you may know, for 2 or 3 or 4 years ago computer. Yes, model analyzed. We'll go back to the ETABS. Here is a deformed shape for the displacement and deformed shape. Then we can see the deformed shape again. Again, it's the self weight, of course. Okay, let's go to analyze. Last analysis run log. Here analysis complete. Here's a number of iterations for the model case. Here Eigen model analysis. Nothing is wrong. Here the cases, linear static cases, linear equation solution, element formation. Everything is fine. No warnings, no errors, no instability conditions. Begin analysis, it means خلاص, up to this title. If nothing is there, it will not be there because the analysis started from here. So everything is fine. Everything is super perfect actually. Finish. Almost, I believe we are done here. Only one last small magic to close the model. Model closed. Thank you. We'll go here. 2 o'clock 1 minute ago because it is saved just before the running. That's it. I believe we are done here. Your feedback is most welcomed and always appreciated. Thank you.